Okay, so in this question we will be solving a sum of the Kruskals algorithm, which is a minimum spanning tree finding algorithm. So it will basically convert this graph into a minimum spanning tree. Okay, so firstly in this graph, what do you say? In this numerical, we need to list down all the edges and their weights. Okay, this is before sorting. Before sorting. And we'll also need another part where after we sort, no, so that will be the after sorting one. We'll have our edges and we'll have our weights. Now we can just go in alphabetical order to get our edges, okay? And edges should not be repeated. Basically, a comma b is the same as b comma a, no? So it should only come once, as there are total 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 edges, right? So we should only get 9 entries in this. Okay, so let's start from A. So we can take A to B and A to C. Okay, so we have A to B with weight 7, A to C with weight 4. Okay, we are done with A. Now let's look at B. Now B comma A and A comma B are the same thing only, so we won't look at that. We'll take, however, B comma C, B comma D, B comma E, B comma C, B comma D, and B comma E, and their weights are 6, 4 and 2, 6, 4 and 2 respectively. Then after that we finish B, no? Then we'll go on to C. Okay, now C comma B is already done, C comma A is also done. So now we only need to look at the ones ahead, that is C comma D and C comma F. So we get one as C comma D, which has weight 8, and we have another that is C comma F with weight 9. Okay, so far we have 1, 2, 3, 4, 5, 6, 7 edges. So we need 2 more, no? Now let's we finished C, no? Let's look at D. So D comma B and D comma C are already done. So we'll only look at D comma E and D comma F. D comma E has a weight of 7 and D comma F has a weight of 1. Since we already got all of our 9 edges, we do not need to check for the remaining vertices, because it's basically just mirror images. Like F comma D and D comma F are the same thing only, na? And we only need 9 of them. Okay, so this will be one table of ours, essay, and then after sorting we can have another one, na? So we'll have edges and weights, and we need to sort it in a decreasing order. Basically in a increasing order, sorry. We'll need the smallest weight up first and the largest weight down below. Okay, so firstly we'll have D comma F here. This is very simple only. We just need to sort it according to the weights. Then we have B comma E, weight 2. Then we have B comma A comma C and B comma D. You can write it in any order, but I prefer to write these in this order because A comes before B, right? Even though the weights are same. वैसे we finish 4, then there's no 5, there's a 6, that is B comma C. Then there are 2 7s, A comma B and D comma E. So A comma B and D comma E will be our 2 weights 7 7. Then we'll have C comma D, which is 8, and lastly we'll have C comma F, which is 9. So this is our edges before sorting, and these are our edges after sorting. Okay, so 1 2 4 4 6 7 8 9. So now before we get started with the minimum spanning tree, okay, you just need to remember one thing. Since there are in this case there are 6 vertices, okay, so then we only need 5 valid edges, only 5, okay, because in a minimum spanning tree, if there are n vertices, in this case 6 n vertices, then there will be only n minus 1 edges. Okay, so basically once we get 5 edges, we can stop running the algorithm. Uske baad we don't care. Okay, so firstly we just make a skeleton, okay, for this, like the skeleton of the graph. It should consider all the vertices. We'll have vertex A, we'll have vertex B, we'll have C here, D, and then we have E and F. Okay, So now we shall this thing start adding the edges one by one. We'll look at the sorted list and we'll see whether there's a cycle formed or not. If anywhere there's a cycle formed, we must reject that edge. Okay. So now if you see, the first edge is from D comma F. So D comma F and edge is 1. Weight is 1. Edge weight is 1. Since there's no cycle formed, we can consider it. So we consider this. This is step 1, no? So now you'll have to draw this, and then for step 2 you'll have to redraw this with whatever is additional. Okay, but since I don't want to redraw it, I'm just going to write step 2 here. Hopefully you understand, like that you need to make the graph over and over again. But yeah, so now for step 2 your graph will look like this. We'll be adding this edge as well, that is B comma E, and its weight is 2. Okay, so we add this over here. This is step 2 completed successfully. That is how the graph will look after step 2. You have to redraw it each time. I'm not doing it. Then we have step 3 though. So now step 3 mein we'll have this edge that is getting added. That is A comma C and has a weight of 4. Okay, edge weight of 4. Now as you can see, we have 3 edges. Step 3 ho gaya. Now we move on to step 4. Again you'll have to redraw this and add one more edge, whichever edge comes. So now you have B comma D with edge weight 4. Okay, so if you look at B comma D, you can connect it edge weight 4. So far we have no cycles formed, no. And let's see how many edges we have. 1 2 3 4. As I said, there are 6 vertices, so we need only one less, that is 5 edges. We already have 4, no, so we are almost there. We just need one more edge. Let's go on to step 5. Okay, so now on step 5, as you can see, step 5 is this one, no? Yeah, so B comma C of 6. So if you go from B to C with a weight of 6, so far there is no cycles formed, no. That is our step 5. Okay, so now since step 5 is done, this is basically a MST. Okay, like we got it, but we'll still have to continue just to what do you say, show that we just to show the steps, I guess. No other reason. Basically now this was step 5, no? We all this will be the final answer. Just for formality, let's look at the what do you say, further steps. So now for the 6th step, as you can see, we'll get this edge A comma B. Okay, but if you see, A comma B leads to this thing, cycle formation. Now if I made this edge, we'll have a loop over here, which is not allowed for a tree. A minimum spanning tree can have no loops. Any tree can have no loops. Okay, so therefore we can just write a statement that since edge A comma C leads to cycle formation, I'm just writing in short, okay, leads to cycle formation, therefore we reject it. Therefore this edge A comma B gets rejected. Sorry, wait, does A comma, this was A comma B, no, I wrote A comma C. Sorry, A comma B leads to cycle formation, so it gets rejected. Similarly, if you look at the next one also, D comma E. Okay, if we make this edge, I mean, you don't need to draw this dotted line also, but I'm just drawing so that you understand. If you make this edge like that, okay, then again we'll get another cycle. No, this is during step 7, the next step. This happened during step 6. Step 6, I'll just write here. This was step 6 wala. So during step 7, we'll have another cycle formed here, no? And we don't need to consider this also, because we don't want any cycles in our graph. So we reject this also, and we can write this same statement in step 7 as well. Just we rejected D comma E, no? So we'll write, since D comma E leads to cycle formation, we reject this edge. Now similarly for step 8, if you look at step 8, when we have C comma D wala edge, C comma D leads to this thing, what do you say, cycle formation again. So we reject that also. This is also rejected. Okay, so therefore C comma D leads to cycle formation, therefore we reject it. Same statement only, but you just need to write it over there. Okay, so this is also done. And then finally in step 9, which is for the last, what do you say, edge, that will also be rejected. As you can see, that too will lead to a cycle formation, so you can write that also. In the last step, C comma F also gets rejected because it leads to cycle formation. And finally you can write this is a minimum spanning tree. If you want, you can these parts shouldn't be there, okay, the crossed out parts. It should be only this. Like if you want, you can redraw it, okay. S A D F. I'm just doing it roughly. You'll have this, you'll have this, you'll have this, this, and this. This is your minimum spanning tree. 2, 4, 1. And now all these edges that are there, no, 4, 6, 4, 2, 1. You need to calculate the sum, okay. So total sum of all edges or edge weights, I wrote in short, edge weights is equal to 4 plus 6, 10, 14, 16, 17. So 17. So for this, what do you say? For this graph, you get a MST having sum of all weights as 17. This is the minimum sum. Still, minimum sum that still keeps to the entire graph connected. So yeah, that's your final answer.